Hello everyone, this is the answer key for exercises for Chapter 2 and Chapter 3. First two problems about Chapter 2 and the next two problems about Chapter 3. I put everything together in the same file because all the problems here are based upon the same data set summarized here. Here we go. The following data table was obtained by a 4th grader on his science project, Exploding Foam. He poured 1/2 teaspoon of baking soda and 1/8 teaspoon of laundry detergent into 1/4 cup of vinegar of various temperature and measured the volume of the foam that rises. And he tried it 19 times. Actually, he tried 20 times, but one of them was an outlier. He forgot to put in laundry detergent and the result was kind of mess. Okay, so we have 19 trials and we have to find out the mean and the standard deviation based upon these 19 trials. How do you do that? Mean is simple. Just add up all the numbers, all the temperatures here, and divide by 19. Just a simple average. You get about 73.7. Standard deviation is a little bit tougher. And here's the formula. Deviation squared. That is the first number minus the mean squared. The next deviation squared. The second number minus the mean squared. Plus third number minus the mean squared, and so on and so forth. And the last one here, minus the mean squared. That's what we have in the numerator. Divided by 19 minus 1 and square root of all these. You see, we squared in the numerator, so we get actually two-dimensional quantity here. So in order to make it fair, we take the square root again and come back to one-dimensional data. Now, why do we have 19 minus 1? That's because 19 minus 1, 18, is so-called a degree of freedom. All these 19 numbers can vary whatever they will when you calculate the mean, but when you calculate the sample standard deviation, not all 19 numbers are varying around at their will because one of them is fixed because of the mean is known, so only 18 numbers can vary at their will. Now, if you do not understand what I just talked about, never mind. It goes way beyond 1000 level of mathematics. I just talked about it just in case there are some students who are interested. Most of the students will just regard this as the formula. Deviation squared plus another deviation squared and so on and so forth, divided by n minus 1, which we call sample variation, and square root of it. Now, one thing that may trap a student is whether this is 19 or 19 minus 1. For population standard deviation, it is capital N, where capital N is the sample size. Capital N is population size. For sample standard deviation, this is n minus 1, where n is sample size. So is 19 the population size or the sample size? That's the problem here. What do you think? Is it sample size or population size? It is sample size for two reasons. Number one, the legitimate reason. Is it possible to repeat this exercise beyond 19? Oh yes, we just pour more laundry detergent and baking soda into vinegar and then repeat this exercise 20 more times. Yes, you can do that. So 19 here is not the kind of number that is carved in stone. You can always change it. So this is sample size, not the population size. That's number one. The second reason, maybe a little of cheating, but it is legitimate, at least in my class. Have I ever emphasized population standard deviation at all in my lectures, in class or in videos? Not at all. Why would I write population standard deviation problem in exercise set? No reason, absolutely not. Everything we do was based upon sample standard deviation in classes, so in exercise set, the same. Don't bother about population standard deviation, at least in my class, at least in 1000 level math course. Okay, that's a bit of a cheating, but it works out. How do we calculate this quantity? Oh my, that's gonna be very unpleasant job if you use handheld calculator. With paper and pencil, of course, it's impossible. So how do you do that with technology? Well, here is Mathematica's way. I typed in all those numbers, and then the commands are mean of this data set or standard deviation of the data set. That's for Mathematica, but not everybody has this expensive software. So let me tell you how to do it with MS Excel. Here we go. MS Excel, and to save some time, I already typed in all the data, all the temperature and all the volume. By the way, these two are based upon Celsius. Let's stick to Fahrenheit and milliliters. And by the way, I told you about outliers, and we got some not so great results because my son forgot to put in the laundry detergent there. So instead of 20 trials, we came down to 19. Okay, let's find out the mean. Alright, let's find out the mean, and the place to go is the sigma symbol in the top right side corner, and click this upside down triangle, and you'll have the extension of all these commands. And let's see, mean actually shows up here, the average. Let's find out the average, but the default cell is not very good. So use your mouse to select your data set. So start from here and drag it all the way over to this data set. Click enter, and that's it. 73.705 something. Is that the same number we got here? Yes. Cannot be coincidence. It must be right. Let's repeat the exercise. Let's do the same thing with volume. How do you do that? Go to this sigma upside down triangle. Average is the mean. This default data set is not right, so you have to select the correct data set with your mouse. And there you go. Okay, mean was not too much of a deal. Standard deviation, that's far more important. So let me show you how. Go to the cell, that's where the standard deviation will go, and go to the same place, the sigma, this triangle, and standard deviation does not show up here, so go to more functions. Now, I already used statistical package, the default is already in statistical, but let's suppose it is in some other place. Suppose that you're using a public computer or you're doing this for the first time. Okay. Go to this upside down triangle and find out appropriate package. And this is statistics course, so naturally you'll have to look for statistical package here. Not the math and trig or some other things. Not engineering, not financial, but statistical. Okay, go to statistical, and we have a lot of functions here, and you have to find a standard deviation. Go down to S. Here we go. Standard deviation.p, this is population standard deviation. We never use it in 1000 level. So here we go. Sample standard deviation. By the way, this absolute standard deviation, we don't use those kind of things either. So standard deviation.s. So sample standard deviation is the only standard deviation we use in 1000 level math course here. Select that. And now you have to select your data set. Do the same thing. Use your mouse to select your data set and click enter or OK. And there you go. 28.17 something. Is that right? 28.17. Yes, it fits. Cannot be coincidence. One more exercise, one more repetition. Okay, here we go. Let's do the same thing with volume. Go to this box where the standard deviation computation will come, and go over to the same place, sigma upside down arrow this one and find more functions. And let's suppose this was in some other place, okay? And go to statistical and find standard deviation.s, sample standard deviation. Alphabetically it's here. Click OK and select your data set with your mouse. You can type in your dataset number directly if you're familiar with MS Excel. Click OK or enter and there you go. That's your sample standard deviation. Okay. Now 5-number summary and box whiskers chart. Looks like we'll have to do this in the next segment of the video. Let's stop here for now.